Okay. Hello, everyone. Let's start by doing, a few announcements, and then we will proceed to other things. So the exam is, at least the exam coding problems will be released on maybe Saturday, I'll say. I might release them early, maybe Friday, but I'm not going to promise that, so maybe on Saturday. You'll have until next Friday, as usual, right? That's a 7-day period. And so, there will be 5 problems, just like a homework. Similar difficulty. The only exception is that they're just going to cover probably everything up to basic functions, so nothing too terribly complex with regard to functions, but we will cover basic functions. Yep. Okay. So when I say it's released on Saturday, I think I'll release it on, that's, 3/6, and it's going to be due, I guess, 3/13. Okay. What else? And then there's going to be a multiple choice section on Blackboard. So the answer to that is you can sign up for office hours. TAs can help. They may help slightly less than with homework, but if you're confused about exactly what the problem means, then that's definitely something the TA will help. That can be helped. Probably not with the MCQ questions, right? So, I mean, they can help you understand a question, but we're not gonna try to. Hopefully, we won't give too many hints as to how to solve the questions, just because it's, it would be unfair if we gave some people hints and some people not hints and stuff like that. So, the multiple choice sections in general, I mean, I shouldn't say this. I think they're relatively easy. I don't make them excessively hard. If you understand the homeworks, if you have done the homeworks, you should be pretty much prepared. Yeah. So yeah, if you do the homeworks, you should be pretty much prepared. You shouldn't have to study for hours and hours and hours to be able to do the multiple choice. Okay. So let's get back to functions. So let's just talk about the parts of a function. Or really, I guess we call it param1. And so here's how you declare a function. And then anyway, so let's see here. So the function name, yep, let's get back to it. So what am I doing? And then here we'll have the function body with code. And so that's it. And then maybe it has some return statements. Let's do return statements. Return some variable. Okay. So the function name, what we usually call this up here, this whole line here, Sometimes we call this the signature of the function. You can call it the declaration, something like that. And the reason why we call it the signature is because it basically tells us everything we need to know about that function. And what I mean by that is it tells us, and I don't know why I'm putting comments in here because this isn't code. It tells us basically the function's name. It tells us all the arguments, parameters, and so that's all you need to know in order to call a function. Okay, and so that's the point here. And then here's the function body with some code in it, right? And this can be any bit of code. The only rule is that it has to be indented, right? So everything inside the function is indented. E-N-T-E-D. There we go. There we are. And so good. Okay. What else should I say about this? So then there's return statements. And that's really it. That's all you have to know. The other bits of terminology for functions is that there's some really technical stuff that I don't actually there's actually there's like one last bit of technicality that I should talk about, and there's that so the names of the variables inside the function signature declaration are called parameters. And then if you, for instance, call the function, right, with say 1, 2, 3, 1, 2, and 3 are called arguments. And so I really don't make much of a distinction between parameters and arguments. The only reason why we might make a distinction between a parameter and an argument is that the argument is the actual value that's being used to call the function. So the argument is the actual value that is being used to call the function, and a parameter is the name we give that value, right? The variable name that's inside the what should we call it? Inside the function itself, right? So that's the distinction, right? So in one case, you have an argument, which is the actual value. So 1, 2, and 3 are the arguments. The parameters, on the other hand, are param1, param2, and param3, right? These variable names are not always 1, 2, and 3. It just happens to be 1, 2, and 3 when we call the function that time. So we would call, and the other thing is that whenever you call a function, I should say that this is just, it's called a function call. Okay? So there we are. Okay, cool. So that's a bit of language that we use to describe functions, but there's nothing terribly, I shouldn't say there's anything terribly shocking or surprising about any of it. There's not a lot of content here. I'm just going over the names of everything. So let's go back and make a new function lecture. Functions 2. Okay. So remember last time we wrote a .lower function? Can you put default parameters? So I haven't taught default parameters yet. I will probably teach them at some point this semester. I'm going to say avoid default parameters right now, just because try to stick to functions. You don't need default parameters for anything yet. As soon as you need a default parameter, I'll teach it. I'm not opposed to default parameters. It's just I try to keep, as horrible as this sounds, I try to keep this class as simple as possible. So okay. Okay, just had a drink. Okay, so let's talk about the .lower right. That's right. The arguments are in the function call, and the parameters are in the... That's exactly right. So remember that last time I made this like dot lower function, and then I promised that we were going to write a mySplit function, which does this more or less the same thing as split. And so, and then I never did that because we ran out of time. So what we're going to do now is just pick up right there. I think it's not a bad, let's delete all this crap and put a pass in here. Remember, pass is a no-op. I was talking about that last time. So it's basically just a grammatical placeholder. And what I mean by grammatical is syntactic. So it doesn't have any meaning. It doesn't tell Python to do anything. In fact, it tells Python to do nothing. But what it also tells Python is, hey, you expected something at this tab level. Well, here's something at this tab level, right? So a pass does nothing. Okay, so how do we do split? So how does split work? Split works by, what it does is it takes a string, right? And then what it does is it basically splits it on white space. So that's what we're going to do here. We're not going to split on any individual character like the other split function does. We're just going to split on white space. And so a string is the string that we input to split by white space. And then here what we're going to do is the return value is going to be a list of strings, right? The result of splitting. So, okay. So what are we going to do now? Right? So let's write this function. Let's try to write it. So I think this is a good example of where we can use a Boolean flag. So I think we're going to have an in-string variable, which will start as false. And then what we'll do is we'll say, we'll have a current string variable, which is an empty string right now. And then we'll have an index, right, which will start at 0. And then I'm going to actually do this with a while loop. So I'm going to do while index is less than the length of a string, right? And the reason why I'm doing that is just because, well, I guess I could do it with a for loop. Let's do it with a for loop. I think a for loop might actually be the right answer here. So for index in range len a string. See, I went back on my word. I was going to try to use a while loop, but I actually think the right answer is to use a for loop. So, okay. And then here we'll have a split list, right? And split list will start out as an empty list. Okay. So what are the possible things that can happen, right? So basically, let's look at like a string like this, list of strings, result of splitting. So if we actually just put quotation marks around this, then the answer is, and let's put a few spaces here, if, right, so we start out as not in a string, and so what we're going to do is we're going to scan through the first white space bits until we get to a non-white space thing. So how do we know that we're in white space, right? How can we tell that we have white space? And I think my answer to this is going to be something on the order of, if it strips to nothing, so I'm going to actually just use strip to write split, but whatever. If it strips to nothing, then it's white space, right? So that's how we can tell. So what if we are not in a string, right? Actually, yeah, let's just do what if in string, we'll do pass else. So now we're not in a string. So if the current character, so a string at index dot strip is false, right? So that means if not that. So what this is doing is this is saying if the value of a string dot strip is false, right? Meaning that not false is true, which means that a string index was white space, right? Because strip is going to delete all the white space, and then a string index, this is just going to test if we have an empty string at the end. So if it strips out all the white space, then we know that we had an empty string. And if we know that we had an empty string, then and we started with a single character, then it had to have deleted that character. So we're being very lazy here. There's other ways to do it. This is just the way I'm going to do it for now. So if the thing is equal to white space, right, and we are not inside of a string, then we do nothing actually. So then actually we do nothing. I don't think we do anything, right? So actually what we really care about is if we're not in a string and the thing isn't white space, then we'll set current string plus equals a string at index, and then we will set in string equals true, and that's what we're going to do. Okay. Otherwise, we just ignore the character, right? Else we just, do nothing. So we don't have to have anything there. So actually, we want it to be true, so, okay. Yep. If this is true, then this was not white space, right? So we set in string to true, and we add the character to a new string. Okay, so now what do we do if we're in a string, right? If we're in a string, what can happen? So there's two possibilities. Either we're here in strip like str, and the next letters say I, so that means that we don't encounter white space. So if we don't encounter white space, right, then what we do is we say current string plus equals a string index. Done. Else, what we do is we say, we did encounter white space. So what we're going to do there is what? I don't know. We'll add the string. So we'll say split list dot append, and we'll append the current string, something like that. And then what we're going to do is what? And then we'll set in string to false. Okay, does this work? I don't know. I think the last thing we have to do is after we get out of the after we get out of the string itself, if we're still in a string, this is the last thing we have to do. And so why do we have to do this at the end? Basically, if we were in a string at the end, we may not actually save it, right? So let's save it. So if we're still in a string, then what we'll do is we'll say split list dot append current string. So, I mean, this is basically the code that you would see for my split. So let's test out my split on something simple like, hello there, we are going to test my split, right? Incidentally, in PyCharm, if you do Control-Alt-L, and I don't know what the command is on a Mac, but if you do Control-Alt-L in Windows, there's a similar command in Macs that uses their own command keys or whatever. But if you do that, then it reformats to fix PEP8 problems, if it can. So you see how it got rid of that underline. Let's see, reformats. Does it not like... Okay, hello there. We're going to test my split. So let's see what happens if we do this, right? Wow. Okay, that was running. This old lecture was running. Okay, let's run functions too. Excellent. So it didn't work. But it didn't work for the stupidest possible reason. what is the literal stupidest possible reason? So what I did was I made the split list. I added all the strings to the split list. And yeah, then I just never bothered to return the split list. Okay, let's try that again. So it didn't work. Cool. So why didn't it work? Let's debug, right? Let's test this thing. So if we're not in a string, and if this index.strip, which means that it's not white space, then we do this and end string is equal to true. So, oh, wow, that was bad. Look at that. I put it in a list. It expects a string, but I put it inside of a list for some reason. That was just, okay, let's try this again. There we go. Excellent. Look at that. Look at that. So it works. Almost. Right? So what do we forget to do? So notice what's happening here, right? It is actually, I mean, it's quote unquote working. Let's put some more scare quotes around that. So it basically works. What's the last thing that we have to do to fix it? Right? So the last thing we have to do to fix it is to just remember to end. I guess I never did that, did I? So here we appended the current string to the list. Yeah, exactly. So we appended the current string to the list, but I never blanked it out. So there we go. There we are. So cool. All right, so let's think of another string, or actually let's just use input. Input tell me a string to split. So let's run it. Let's do something. Right, so what happens if we just try to split a single word, right? And so this is kind of an introduction to the idea of test cases, right? So think about the things that can go wrong, right? So the first thing we should try is maybe even try to split nothing, right? So let's split nothing. Cool, so that worked, right? Because if we split nothing, this is an empty string that we feed in. It should not have anything pop out, so that's right. Well, actually, it should. I shouldn't say nothing. It should have this empty list pop out, which is what happens. So let's just do a while loop while s is not equal to quit, and then we will do s equals input, and we'll put that here, and we will print my split s. Do this. Okay. So. So the empty string worked. How about something with a single? What about something that's just like tabs and spaces, right? Just all white space. So this should also strip to nothing. Let's see what happens. Cool. So that worked. So basically, it's hard to tell what that test was, but that test was actually just I was just hitting space and tab a bunch of times. So that's another test. Okay. How about a single word? Right? Cool. How about 2 words? Very good. 3 words are 3 words test, right? How about something where we have 3 with only tabs, words, test, right? With some tabs afterwards. Cool. So it looks like we've tested out a lot of different conditions. And I think that this would probably be a pretty good estimate as to whether it worked. Now, of course, the thing is that we're not actually testing any new line characters, so technically it could fail on new line characters. But that's really relying on the strip functionality. So, so hopefully we don't. So hopefully strip isn't broken. So what other kinds of things would we have to test, right? Hard to think about, really. I mean, we tested just white space, we tested an empty string, we tested a single word. The single word is really the important thing to test, because sometimes that could fail. The other thing is that it's important to test whether or not, for instance, it works if there's space after the last word, right, or not. So no space after the last word, right? And the reason why it's important to test that is because, as you see here, this line, if we didn't include this line, right, this little exception here, if we didn't include it, then what would happen is if we had something like, here is a set of strings, and we put a space here, enter, see, that worked, right? But I'm going to say that worked, and then you see, oh, wait a second, what happened to worked, right? And you see that it's killing off the last word, because what's happening is the string ends, so this for loop ends, but the thing is that the last letter that it checked was actually not white space. So because the last thing it checked wasn't white space, it never appended, right? It only appends if we're in a string and if the thing is white space, right? This means not white space, right? Basically, this line means not white space. So this line would mean, right? So the else statement means white space, right? And so it means that we're in a string and we encounter white space. But the problem is once the string ends, we don't encounter anything, right? And so that's why we need these extra lines of code, so that we're in a string. It doesn't matter if the last thing that we encountered was white space or not. If we're still in a string, then the last thing we encountered was definitely not white space. So, add it to the list, right? And so that'll make sure that we get the last thing. So that's the reason why you might want to test something like this, because the thing is, like, sometimes it works if you have some extra white space, but then it wouldn't work if you didn't, right? And see here, no extra white space, but here it works again because I put these two lines back. So I think that's basically all the testing that we really should do for this, right? I think it's also a good example of the fact that the split function that Python has is actually more complicated than this, right? Like this is a very simplified version of the split function because it only splits on white space. But this is basically what they're doing anyway in that function, right? So, okay. All right, so I think that's good, right? It feels good to write. The reason why you might say, well, why would you ever rewrite the split function? The answer is, in your actual life, you never would, right? You would just use the internal Python built-in split function. The only reason why we're doing this is for, educational purposes, for thinking through the problem, for trying to understand what's going on, right? That's why we're doing it. We're not doing it because we're legitimately in need of this thing, right? This thing already exists. Okay. Cool. Maybe, I don't know. I mean, it's not always a bad idea. And you see that it's not actually impossible. I mean, you might not been able to do it at the speed that I did it, but you could have eventually probably figured something like this out. And plus, now that you have this as an example, you can use these kinds of ideas. The reason why so let me also say the reason what I do in these examples. So here, what are we showing in this function? Like, why did I do this as an example? We did this as an example because I get to show you list append again, right? I get to show you the append function. I get to show you flag variables, right? I get to show you using temporary variables to store parts of an answer. I get to show you using the basically having two different cases, right? Splitting into cases, right? Either you're in a string or you're not in a string. Well, I'm not going to tell you that, but I mean probably not, since rewriting. Well, I mean rewriting a strip is actually much easier. That would be a decent problem, but I don't know. I haven't made a decision on that. I don't usually assign stuff like this. As I don't usually say rewrite functions that are already written, but whatever. I mean, I could. Okay, so let's remind ourselves. Excess white space at the start end is not. It's definitely considered. Well, so it's definitely considered to be part of a string. It's just when you do the split function, if you do our split function or the regular split function, it ignores the white space at the beginning and the end too. So it's like you call it strip on it anyway. So some people actually do like s.strip.split like this. I've seen this a lot in old Python code. But actually all you need is s.split, because we'll do the stripping for you. Right? So, I mean, yeah. Trust me though, I've seen this in professional code, so I imagine that maybe in some version of Python one of these functions was slightly different, or maybe the programmers are just scared, or who knows exactly why they did this, but they don't have to. Okay. So, can a parameter in a function be another function? Yes, but not in this class. That's, I mean, you would call that like a function pointer or a function reference or something like that. And I promise you we are not doing that in this class, because that's some strange stuff that gets beyond the scope of the course. Okay. So let's do a refresher on prime numbers. So what is a prime number? Oh, I love function pointers. I don't want to teach them because they're definitely very difficult to understand. So, okay. So what is a prime number? A prime number is some, let's just say natural number. So that means like bigger than 1. So note that 1 is not prime, just by definition. So that, yeah, no more than 2 divisors. It is divisible only by 1 and itself, right? Or as you say, only 2 divisors, meaning 1 and itself, or whatever you want to say. So basically, let's think of, so what kind of numbers are prime and what kind of numbers are not prime. So 2 is prime because basically there's nothing else to divide it other than 1 and 2. 3 is prime because 2 doesn't divide it. 4 is not prime, right? So no to 4. How about 5? 5 is prime because 1 divides it, 2 doesn't, 3 doesn't, 4 doesn't, 5 does, right? So I'm going to stop saying 1 and 5 because, pointless. How about 6? Right? 6 is not prime because 6 divided by 2 is equal to 3. 3 divided by 2 is equal to... 6 divided by 3 is equal to 2. I was about to say something like 2 divided by 3 is equal to 6 or something like that. That's what happens when you just kind of get into a rhythm of saying words. So 6 isn't prime, and we know that because when we scan through, right, 1, 2, 3, 4, 5, we find that some of them divide evenly. 7 is prime. 8 is not prime because 2 divides it, 4 divides it. What about 9? 9 is the engineer's prime, which is not a prime, right? And then like 11 is prime, 13 is prime, etc. So let's write an is prime function. Okay? I mean, it's kind of a joke. The engineer's prime, it's kind of a joke. It's basically like saying engineers go based off of patterns, and so they see, well, 3 is prime, 5 is prime, 7 is prime, so they're like, well, okay, odd integers are prime, right? So 9 is 2, right? But anyway, so how do we detect if something is prime? So let's do the algorithm, the simplest possible algorithm, which is the one that I was basically describing when we were testing things, right? So how, which is actually, it has a name. It's called the sieve of Eratosthenes, but we're not even going to do that. It's something even much more simple than that. So, yeah. So there are actually approximate primes. There are like statistical primes out there that you can determine by using various primality tests, which are actually statistical rather than being deterministic. But so what we're going to do, I think the simplest way to determine if something is prime is this. We're going to go for I in range, and then we're going to start at 2, and we're going to go up to n minus... actually, no, I'm sorry. We're going to go up to n because, as you know, this will go up to n minus 1 but not include n. So why don't we start at 1? And the answer is because 1 divides everything evenly, so it's isn't helpful, right? So then think about it this way. What if it divides evenly? So how can we tell if something divides evenly, right? There's a specific special operation we learned in this class that does that for us, right? Yeah, so let's use mod, because mod, and that's not the mod operator, that's the mod operator. So if n mod I is equal to 0, right, then we know that the thing, you could use integer division, right? You could use it. In some programming languages, or if you don't have mod, then another way to determine if things divide evenly is to do something like if n divided by I, right, is equal to n divided by I, like that. So you do an integer division there, right? And so you say if it doesn't have a fractional part, right? Now, this is terrible, so don't do that. Just use mod. This is the way cleaner way to do it. Way cleaner than asking for, fractional remainders. But what if something does divide it? So if something does divide it, then the point is that we have a number that divides n that isn't 1, because we never actually look at 1. And it's not the number itself, because this only goes up to n minus 1. So then we know that this number is not prime. So there's 2 ways that we can handle this. The first way we can handle it is having a is prime flag, and we set it to true. And then here we can set is prime flag to false. And then we'll just return is prime flag, right? And the reason why it'll do the right thing is because if the thing is prime, then this if statement will never be executed. If this if statement is never executed, then it will stay true forever, and it will return true. But if it's divisible by something, then it'll set it to false, and then it'll just be false. So this is one way to do it. But there's actually an even easier way to do it, which is this. So this is the even easier way to do it. And the reason why it's even easier is because as soon as it's divisible by one of those things, you know that you don't have to worry about it ever again, right? So if we find out that, say, 8 is divisible by 2, we don't have to keep going until we find that it's also divisible by 4. Same thing with 6. We find 6 is divisible by 2. It doesn't matter that it's divisible by 3, right? Because we know it's already not prime. Numbers like 24, right, are divisible by like 2, 3, 4, 6, 8, 12, etc. So the thing is, it's divisible by so many different numbers, but we don't care as soon as we find out it's divisible by 2. Like, same thing with 15. 15, we can find out it's divisible by 3. We don't have to check if it's divisible by 4 or 5 or 6, right? It's already not prime because of the rule about primes. So basically what's going to happen is that this for loop is going to run until we find out that it's not prime, and then we just boot out of the function, right? So that's what this does to us. As soon as we hit something that makes it not prime, it just instantly returns false. It never actually gets to here. So that's kind of the point. So let's test out this function, right? Let's test it. Let's do is prime 3. Actually, you know what? Let's just do it this way. For I in range 100, print I is prime I. So hopefully this will tell us, and hopefully we know all the primes, right? So let's do it. All right, so we have all this stuff. So 0, it says is true, so that's not right. And 1 it says is true, so that's not right. So what we need to do is we need to add a little bit of an edge case here. You know, they call these edge cases, meaning they're on the edge of the input spectrum. And so here we're going to say if n is equal to 0 or n is equal to 1, then return false. And now you might say, well, 1 is only divisible by 1 on itself, so shouldn't it be prime? And the answer is actually that it was prime. In the 1800s, they didn't define it this way. The reason why we define 1 to be not prime now is so that the fundamental theorem of arithmetic works. So anyway, so if it's n equals 0 or n equals 1, we just return false. So let's try this again, right? And then we look at all the numbers. So 0 is false, 1 is false. We've made that flip manually. Yeah, I guess if you say that if it has only 2, yeah, if 2 or fewer divisors, then that makes it prime again. So 2 is prime, 3 is prime, 4 ain't, 5 is, 6 isn't, 7 is, 8 engineer's prime is not prime, 10, 11, yep, 13, yep, 14, 15, 16, 17, yep, 18, yep, 19, right? And so you can kind of track through here, and you can tell that this is doing the right thing, right? 23 is prime, 29 is prime, 31 is prime, then you have to go up to 37, 39 is not prime because it's 13 times 3, 41, 43, let's see, 47, yep. So 51 is always the tricky one, right? 51, you might feel like it should be prime, but it's not prime because it's equal to 17 times 3. And yeah, that's always the one that kind of, it can feel wrong sometimes, but it's not actually prime. 53 is, though. Let's see what else we got. 59 seems right. Pretty good, huh? Pretty good. I think we've got it. I think we've got it. And I mean, technically, if we were going to be really careful, we shouldn't just scan past 20 or 30 values, but yeah. So this is a way to tell if something is prime, and so this is a good little example of a function. Okay. Cool. So I think the next thing to talk about is just more about the idea of local variables versus global variables. So local variables live inside of functions, and their lifetime is only as long as the function exists, right? And I've shown you that last time. But also, the other point is that well, let me just show you how this works. So for instance here, and let's say the string, right? So we're going to print out the string, and then we're going to modify it. We're going to say the string is now equal to hello there, and then we are going to print out the string, right? And then here what we're going to do is we're going to say modify string, definitely not hello there, no way, no how. And we'll say result is equal to this, and then we'll print out the result. Okay, so here's the first example I really have of like, what's the problem here? Oh, it doesn't return anything. Oh, I guess we actually don't want to do that. So let me just say, you know, my favorite string is equal to this thing here. And then we'll do modify string on my favorite string. And then we'll print out the string again. Okay, so what's going to happen here? So what's going to happen is that we're going to go into this function. In fact, we can even debug this thing, so let's just watch it happen. So let's step into and then step into. Okay, so the first thing that's going to happen is it's going to print out the string. There we go. So definitely not the thing that we don't want. And then we assign it. And now we're going to print it again. Okay. So we've definitely modified the string, right? My favorite string is modified, isn't it? Right? It's changed. Okay. Now let's print it out and see what happens. Okay. Almost. Huh. What happened? Right? What happened here? So what happened here is we modify the string inside of the function, but when we exit the function, we notice that it didn't modify. So you know, basically this function is a lie. Now, why is this function a lie? Right? Right? Why did it not modify the value of the string, right? We modified it inside of the function. Why did it not modify? The answer is there are, so that's one of the reasons, is that we didn't return it. But we set the string equals this thing right here, and we saw that it printed out right here, right? We saw it. It was, this variable here was changed, right? So why was this variable not changed? Because we passed this variable in as an argument, right? This the string is just some kind of, but then when it came out, it was the same variable, right? So my favorite string never actually got changed, right? So yeah, my favorite string never got changed, even though the string did. That's correct. So why did it modify, right? Why did it modify the string but not my favorite string? And there's an answer. There's an answer to that question. The answer to that question is that in Python, types are divided into two types. And so let's not say that. Two, say, groups. There are the immutable types, and there are the mutable types. Okay? And so in Python, the things that are immutable are things like int, float, bool, and string. And then there's some other things that you'll learn about later on, like for instance, date time is actually an immutable, and the tuples are an immutable, and there's a bunch of other immutables. Things that are immutable. lists. That's basically all you know right now, but also dictionaries when we get to them, and classes when we get to them. So basically you can put like a when we get to them on these. But the point is that there are some mutable things, and the only mutable thing we currently know is a list. But the rest of the stuff is immutable. And so what that means is when you pass it into a function, it passes by value. And so what it means to pass by value is that it makes a copy of the value into the new variable. So the string isn't actually my favorite string. Okay? What it is a copy. Right? So, let's test the same thing out for integers. Let's say modify my int, right? And so let's say my int, right? And what we're going to do here is we're going to say my int plus equals my int, squared minus 2 plus 5 times my int. Okay. Fair enough, right? So it's some garbage, right? We're just going to change the number. So then we're going to print my int, and then we're going to do the same thing here. So we're going to test the same property out. So, let's say favorite integer equals 17, and then we're going to modify this integer, right? We're modifying it, doing the same thing we did before. We're saying plus equals, which is going to do some modification. We're going to print it out, and then afterwards we're going to print out favorite integer. So let's see what happens here. Let's run this thing. So 389 pops out when it prints the first one. So my int gets modified, but then favorite integer doesn't get modified. Okay? And so, again, you might ask, but why? And so then I have to go back to the explanation, right? Int is one of the quote-unquote immutable types. And so when it's immutable, it gets passed by value, and when it gets passed by value, it makes a copy. It's not the original data element. Right, memory location, like whatever you choose to describe a variable as, it's not the original variable. It's a new variable that only exists in this function. And so you see a slight advantage. So there's actually like a little bit of an advantage with this. You can pass immutable things to a function and be sure that it won't mess them up, right? So as long as you don't do any squirrely stuff with global variables, which I'll show you how to do so that I can tell you not to do it. So you can pass immutable things into a function, and then you know that it's not going to screw them up. And the reason why you know it's not going to screw them up is because you know that it's making a copy of the value, so it won't be destroyed by the function call, right? And it is a slight concern, right? If, say you're calling a function some, unknown function that you know that it's going to do something, but you don't know what it's going to do to the data elements. Maybe it actually screws up the arguments that you pass in. The answer is, if you pass in a string, a bool, an int, a float, a date, time, a tuple, something like that, it can't mess those variables up because those variables are considered immutable. And of course you might be like, well, what's a date time object? The answer is it's an object that contains some dates and times. So, but the point is you don't have to care about what they are. All you have to know is that whenever you see one, it's an immutable object and it isn't modified when you send it into a function, right? Because it's making a copy. Okay. So now let's do the other thing. So we have modify my string. We have modify my int. So I'm pretty convinced that at this point you should agree that if it works this way for string and int, I promise you it works the same way for float and bool. I'm not gonna do the same exact thing for float and bool, right? So, but let's do one last one. So the last one that I'm gonna do is say modify my list, right? And then we're gonna do test list, right? And let's do a def on that so that we define it. And then here we're going to say, you know, test list dot append, hello, test list dot append. Why no return on the modify functions? Because they don't have to. I mean, so the thing is that if you actually want to get the return value, so if you want, like, for instance, if you want to do something like this and return my int, and then you say, here, what we're going to do is we're going to say, favorite integer is equal to 17, result is equal to this. What you see is that we can actually get that value back. But my point is that, my point isn't that you can't return it. You can definitely return the value. My point is that the original variable doesn't get modified. So for instance, if you notice here, the original variable doesn't get modified. The result is different, right? The result, this thing when you return my int, it is different. But that's how you retrieve the result from inside of a function, right? Is you return it. So I'm just trying to distinguish those two things. So in one case, we're getting a result from a function. In the other case, we know that we're not changing a parameter or an argument or whatever you want to call it as it's getting shoved into a function. Okay, and so let's do a modify my list, and then we're going to do this, and what we're going to do is say append hello, and then we're going to say, you know, if robot in test list, right, test list dot remove robot. Okay, and so there we are. So we're going to append hello to the end, and if the word robot's in there, we're going to remove it. So let's see what happens. Let's see, modify my list, and then we'll do greatest list ever, right? The greatest list ever is going to be what? It's going to be robot, you know, tag, fishing, scrumptious, deleterious, foible. Okay. No, you don't have to return anything. So the thing is that not every function needs a return value. And the reason why not every function needs a return value, no, he asked a separate. It was a slightly different question. So I think it's still okay to say that not every function needs a return value, and the reason why not every function needs a return value is because sometimes a function is just going to do some operation. So for instance, like if you have a function that's going to connect you to a server, right? Or if you have a function that's just going to print out a grid, that function doesn't need to return anything, right? That function can just do its job, and then it's done, right? And that's fine. So not every function has to return. Remember that if a function doesn't return, there's a secret return none at the end. So that's what happens if you do something like this, where you say result is equal to this, and here we do this, and then what are we going to do? We're going to say, let's see, function modify my list doesn't return anything. That's not 100% true, even though PyCharm is usually pretty correct on things. It's not 100% true. It will return something, even though you don't have a return statement. So print out the greatest list ever and result. Okay? So let's see what happens when we do this, and it hurts me to see all that yellow underlining, but whatever. So you see here that what happened is we appended hello to the end of the list, right? And we removed the robot from the list. And you might be asking, wait, you know, you were just saying that functions don't modify their arguments. And so, you know, that's the whole point of the immutable versus mutable debate question, whatever, right? So that's the whole point here, is that if the thing is immutable, so if it's a float, int, bool, string, it doesn't modify it. But strings are mutable. Oh, I mean, not strings. Lists are mutable. So lists are mutable, which means that when you pass them into a function, there is a danger. Now, a lot of functions are going to be good, right? So functions are, most professionally good code functions, most functions will be good. So if you pass a list into that function, you have a high chance of expecting that, unless you know that it's supposed to butcher the thing, it's not going to do anything to it. But there's always a chance in Python, and so in Python you have to trust the code you're calling. There's in other languages like C++, you can pass things by reference or pass things by value explicitly. You can make the decision as to whether or not to pass them by reference or value. In Python, so like in other languages, in like C++, there's a reference operator. So you put this on a variable. So instead of having something like this, if you wanted it to be a reference, you would be like this, like list. This is what you would do in like C++. You make a list reference. And what this does is it says, don't make a copy, use the original thing. Versus if you just had like this, it would just make a copy. So in C++, there's a reference operator which allows us to choose which thing we want, right? And the only reason why I say C++ is because that's pretty much the next language that you're going to learn. But in Python, different. You never choose, right? Whether to pass something by reference or pass something by value. It's entirely decided by the, what should I say? It's entirely decided by the nature of the variable, right? Basically, whether it's called an immutable variable or a mutable variable. So there's no special marking that you can put on a variable. So what is passing by reference? Passing by reference is the opposite of passing by value. So remember up here where I was saying, when you pass something into a function, it passes by value, right, for an immutable object. So when it passes, when you pass a mutable object into a function, it passes by reference. And by reference, what does that mean? That means it's not making a copy. What it means is that the name of the variable is a secret placeholder for the other variable, right? They're both actually looking at the same underlying memory space. So for instance, basically the way I draw it is that so here's passing by value, and here's passing by reference. And so here's the global variable, and here's the function, so we'll call this the local variable. And we'll do the same thing here. So the global variable, right? My global is going to basically be pointing at this thing, right? And so when we pass something by value, we pass it into a function, and what happens is we have my local variable, so local, here we are. And so what happens is this gets copied, right? Right, and so this is what it means to pass by value, is that you have a global variable, and then when you pass it into a function, it passes by value, so it makes a copy. So the passing by reference is different because let's actually make a copy of all this, but we're not just because I made the copy doesn't mean this is passing by reference. So passing by reference is what happens here. So here's the global variable. There is no actual, the local variable name exists, but what happens to pass by reference is that the local variable actually is just pointing here, right? So that's actually what's happening. So this is the difference between passing by value, where you make a copy and you get a new variable. So this variable only lives as long as the function lives. So as soon as the function dies, this variable dies, and that's why this variable isn't changed. But when you pass by reference, what happens is that the local variable is just a placeholder name, right? It's just a pretend fake name. Well, you could even call it an alias for the global variable. It's an alias that you get to use in the function. So my local as an alias for in the function whatever, right? And the name my local dies when the function dies, ends, right? So just like in passing by value, when a local variable disappears, this name doesn't exist anymore. So my local won't exist anymore. But the value or the actual memory, right, is the global variable. So it's being changed by the function. So that's a distinction between I shouldn't say local and global. That's a distinction between value passing and reference passing. And as I say, the decision as to whether something is by value or reference is entirely based on the immutable value or mutable reference. So this does not carry over to all other languages, right? This is a very Python-specific thing, right? Python-specific. But in other languages, there are other ways to handle it. So every language has its own little way of handling it. This is just what Python does to handle it. They've kind of said that anything that's immutable just always makes a copy. Anything that's mutable does this behavior. So, yeah, okay. What else we got? What else do we have? I guess let's do one last example of a function. So I think this was good because maybe this made sense. Who knows? Well, let's not do list slicing because doesn't have anything to do with functions right now. We'll go back to list slicing in a different lecture. I think the last thing to do is let's talk about palindromes. And the reason why palindrome is such a good problem, so you might think palindromes are pointless. I agree. But they're a great problem. And here's why. They require you to think about indices in strings. Okay? So what the heck is a palindrome? So a palindrome is something like race car. Of course, you might say, well, isn't there a space there? I say, not if it's a palindrome. You know, a man, a plan, what is it? Canal, Panama? Is that one of them? So basically, I think that is a palindrome. Yeah, Taco Cat. That's right. That's one that I used in my lecture notes that I have on the thingy. Yeah, so whatever is spelled forwards and backwards, and generally you ignore spaces. So let's think about how to scan through a string. Well, basically, here's the short and long of it. A palindrome is something that's like this: A, B, C, D, C, B, A. Something that is the same if you reverse it. Now, so how would we attack a problem like this? The way I think the best way to attack a problem like this is to look at it from the perspective of Well, what index has to match with what index, right? So basically, if this is index 0, then this has to match with index length minus 1, right? So index 0 has to match with length minus 1. Index 1 has to match with index length minus 2. Index 2 has to match with index length minus 3. All the way down to whenever we get to the middle and we can stop there, right? I actually never heard of that. So basically, I think the way to do it, one way to do it, is you can say for I in range, len test pal. That's right. There is a formula you can use, right? Because here you have to check if I matches with the length minus 1 minus I, as it turns out, right? Or you can do length minus I minus 1, whatever, right? Basically, the whole point, or you can say this is 1 plus I, right? Like this. I don't really care how you do your order of operations as long as you get it right. So basically what we can do here is we can say if the test pal at I is not equal to test pal at length of test pal minus 1 minus I, then we can return false. So this feels a lot like the prime testing, doesn't it? A lot like prime testing. And then at the end, we just return true. All right, so let's do some is palindromes, right? Let's actually steal that while loop that I had earlier. I want to steal a while loop. Here we go. The reason why I want to steal this while loop is just so that we can get through this quickly. So test for pals. And so then here we'll, instead of doing my split, we'll just do is palindrome. And I think that's all we need, right? So let's see what happens when we run this. Let's do race car. True. What about the letter A? True. Why is that a palindrome? That's a palindrome because A reversed is just A, right? Taco cat. A man, a plan, a canal. Panama? No, a man, a plan. Is that right? True. Oh, that's right. Gara Farrig. I hope that's not something horrible. True. A, B, C, D, C, B, A. So, cool. We've done a bunch of trues. Now let's do some falses, right? So remember when you're doing testing of your functions, it's important to test things that match both conditions. So, okay, Pokemon. Couldn't you make a program that makes palindromes? Yes, you could. Yes, you could. Pokemon is not a palindrome, which is good because P and N don't match. How about A, B, C, D, E, F, G? Not a palindrome. How about A, B, C, D, B, B, A, right? The only place it doesn't match is here, where the C doesn't match. And then what about A, B, C, D, D, C, B, A? So it's important. The reason why this is good, yeah, so that works, but palindrome. So palindrome is not a palindrome, but, you know, whatever. Okay. So I think that's a good place to stop for today. I think we've actually covered a lot. I think really the whole point of today was just to go over local and global variables, to go over passing by value versus passing by reference, and to just, yeah, well, we just need to invent a new word that is, you know, a palinap, palin-illap. So if we just called it, if we just called it palindrome, then palindromes are palindromes. But unfortunately, palindromes are, the word palindrome is not itself a palindrome, but palindrome is a palindrome. So, yep. So basically the whole point of this class was local and global variables, passing by reference versus passing by value, and talking about mutability. And also just doing examples of functions, right? So examples of functions. And the reason why examples of functions are important is because I feel like it's one of those things that is difficult to do if you don't have a lot of examples. You should use the examples that we do in class to help you solve things in the future, because the examples that I do here are directly related to the kinds of things that I expect you to be able to do in homework and stuff. So I don't expect you to reinvent everything from programming, but I do, can a palindrome have spaces? The answer is yes, it can. Generally, what you do is you will actually strip out all the spaces and then count it like that. That's usually the tradition. If you're a computer, on the other hand, what you'll do is you'll just look at it directly, and the spaces have to match too. But yeah, so if you want to strip out all the spaces out of something, you can always do something like s.split, right? And then you do a null string dot join like that. And so what this will do is it'll take out. So if we do something like this and we say, let's. All right, so we do s is equal to this, and we can print out s. Right, so this is generally what you would do if you wanted to take out all the spaces, to take out all of the spaces before we test. And so this is generally how people do palindromes. So you could say, is race car a palindrome? And the answer is yes, but we strip out the string, or taco cat, yes. If you didn't do this, if you just let it go as is, then the O wouldn't match with the space, so it would be false. All right, I think that's it for today, really. I think we're good. That's pretty good. I like that one. Wow. I mean, we should that could be a little extra credit project, is take the dictionary and try to make palindromes out of combinations of words and stuff. Just search for it. Not sure that's an actual project or anything, or I'm not sure I can make that into a homework or a project. I don't think it's exactly amenable, but whatever. All right, have a good day, everyone. This was fun. Oh, I mean, I want 400,000 palindromes. I don't know. I mean, right? Okay, signing off.